Intermediate Algebra, Mat 1033, Chapter 2, Section 4, which is inequalities. All right, first of all, we solve inequalities algebraically just like we do equalities, except for one exception, and I'll explain that when we get to it. Make sure you understand that you may have been accustomed to using an open point. Well, now you're going to use parentheses. Open point or parentheses goes with less than or greater than. The parentheses always opens to the direction that the arrow's pointing. So this would be for greater than, this would be for less than. If I have a closed point, I have brackets. And this goes with less than or equal to, greater than or equal to. Very, very important. Because when you work a problem for me, you're going to have to give me three answers. The algebraic notation, which deals with these symbols, the interval notation, which deals with these, and then the graphical notation. And here's example 3. It says 3x plus 4 will greater than or equal to 2x minus 1. And when we look at that, first thing we're going to do is just use our rules of algebra. I'm going to take this 2x and move it over here by subtracting. That gives me x plus 4 greater than or equal to negative 6. Subtract the 4. I get x is greater than or equal to negative 10. Here's my algebraic notation. So anytime I solve it algebraically, I have the algebraic notation. Notice also that the arrow points in the direction I'm going to shade. This is greater than. So the graph is a bracket at negative 10 and shading to the right. The interval would, we read graphs as we come from left to right. So as I come from the left side to the right, the first thing I hit is the bracket negative 10. Where I'm heading as I continue is to positive infinity. Infinity signs, whether it's negative infinity or positive infinity, always has a parenthesis. We'll come over here to example 5. Same thing. It's a multi-step algebraic problem. We're going to use our rules. So the first thing I did here was distribute the negative. So I got negative x plus 3 plus 2. Here I distributed 3, so I get 6x minus 15 plus x. Now, in the second step, I'm going to combine like terms. I get negative x plus 5 less than or equal to 7x minus 15. And then I'm going to subtract this 7x over to the other side. Remember, we wanted a two-step form. And we have negative x plus 5 less than or equal to negative 15. Now, the reason we want it in two-step form is because, first of all, our first step is to subtract 5. Our second step is divide by negative 8. Anytime the number with the variable is a negative and it's an inequality, we have to flip the sign. So two-step form not only gives us our two steps, but also tells us whether we're going to have to flip or not the sign. So subtract 5, we get negative 8x less than or equal to negative 20. Divide by the negative 8, flip the sign. We get x is greater than or equal to 20 over 8, which reduces to 5 halves. Coming down here, and it's greater than or equal to. So as we come from the from the left, first thing we hit is bracket 5 halves. We're continuing to positive infinity. And there's our interval. Example 6, the last example for this section. Again, multi-step algebraic problem. Because we have the fraction, we want to get rid of the fraction. So we're going to multiply this whole thing by 5 over 1. Now, watch what happens though. Because we're going to multiply 5 over 1 times 2/5, we get 2. We don't have to multiply inside the parentheses, because this combination of multiplication will be distributed with the 2. So the 2 will have the 5 over 1 times the 2 over 5 in it. We still have to multiply 5 times x. We still have to multiply 5 times 1. Remember, what we do to one side, we've got to do to the other side. We distribute the 2. We get 2x minus 12 greater than or equal to 5x minus 5. Subtract the 5x over, we get negative 3x minus 12 greater than or equal to negative 5. I can see that I'm going to have to add 12, divide by negative 3, and flip the sign. So I get negative 3x greater than or equal to 7. I get x less than or equal to negative 7/3. I come down here, and this one, because it's less than or equal to, I'm coming from negative infinity. Because the arrow is telling me to shade this way. I'm ending at bracket negative 7/3. So the interval notation and the graph hold true. See how the interval notation says we're coming from negative infinity, but we're stopping at negative 7/3? Also, in your book, on page 80, there's an excellent chart which shows you all possible combinations that you will have for, as I should say, algebraic notation, which is this first column. They're calling it set notation. I call it algebraic notation. Graphical notation, and interval notation. So if you have a problem with understanding how the interval matches to the graph matches to the algebra, or vice versa on any of them, refer back to this chart because it'll help you. Once again, that's on page 80, chapter 2.